This is video number 1 for section 5.3, definition of a logarithm. We have a new tool to introduce in this lesson, and that new tool is called a logarithm. This is something you may not have done before, so I want to make sure you understand what this is talking about. If you would like, I'll give you a more thorough definition in a moment, but if you would like maybe just a single synonym definition for logarithm, the word would be power. A logarithm is just a power, an exponent, in other words. It essentially gives you a way to talk about a specific power. For example, take a look at this simple example. We use powers all the time, right? Exponents. This one says 4 to the second power is 16. That little 2 there is an example of a power. And if I were to say, well, what power is it? You might say, oh, it's the power that you have to put on top of the 4 in order to end up with 16. Well, a logarithm just gives you a way to write down what I just said. We write log. Just below, as a subscript, we put the base, the 4. And right on the main line, next to the log, we put the 16. This is read log base 4 of 16. And it simply means the power of 4 that results in 16. In other words, the 4 is the base, the 16 is the final result. The logarithm itself is equal to the power, which of course we have already said is 2. Every log is just an exponent. That's all it is. It's just a power. Let me now write down for you a more full definition. When we have log base b of x, that's how you would read that, log base b of x, it simply means the power of b that results in x. You really need to learn and memorize this definition. What I always remember is the little guy, the number that's written as a subscript, that's always the base that you're talking about in that problem. The other one, the guy written on the main line next to the logarithm, that's the result. In other words, the final result of using the base and the power. And the logarithm itself is equal to, what are you looking for? You're looking for the power. You're given the base, you're given the final result, you're looking for the power. All right, let's try this in some examples, and I think this will help this definition to make a little more sense. I just have several here. You're welcome to try them on your own first if you would like, but let me start walking you through them. So this first one, you would read log base 2 of 32. Log base 2 of 32. One thing I think that helps when you're first learning how to do this is maybe to go off on the side. Don't take up this space with scratch work. This is where the final answer goes. Do your scratch work off to the side. What does this mean? Well, that little 2 is a base. I'm looking for a power. Remember, logs are powers. I'm looking for a power, and my result of using that power is 32. So log base 2 of 32 simply means what goes in that box. What power of 2 results in 32? Well, the idea in all of these is that we're able to work them out by hand. If you can work them out by hand, then it must be a reasonably nice answer. Let's see, how many 2's would it take to make 32? 2 times 2 would be 4, times another 2 would be 8, times another 2 would be 16, times another 2 would be 32. So I think I just used 5 2's in all. Whatever goes in that box, that's the answer to the logarithm. The logarithm is asking you for the power. Okay, how about the next one? Log base 3 of 27. I think this one is similar. 3 is the base. I don't know the power. 27 is the final result. I just need to figure out how many 3's it takes to get up to 27. well, let's see, 3 times 3 would be 9, times one more 3 would be 27. So I think I just used 3 threes in all. The power is the answer. Again, make sure your scratch work is off to the side somewhere. Okay, how about another one? Log base 77 of 77. Sounds like a strange one, but if you give it some thought for a moment, it's not so bad. This would be base 77. I don't know the power. The final result is also 77. Well, there's only one exponent that keeps the base the same, and that would be an exponent of 1. 77 to the 1 is 77. Again, the exponent is the answer. The power is the answer. Okay, these are going to start to get a little trickier now. So far, the exponents have just been nice, simple, positive integers. But remember, we've learned about several other kinds of exponents, and we're going to have to think about some of those as we keep going. Let's see. This next one, log base 4 of 1. So that would mean 4 to the I don't know equals 1. Now, as soon as I write that down, I'm thinking, okay, something strange must be going on with this one. How do you start with a 4 and actually end up smaller? Well, the only way that could happen is if this has to do with one of our stranger types of exponents. And hopefully what's coming into your mind is this special exponent we learned about that turns any base into a 1. That was a 0 exponent, right? 4 to the 0 equals 1. The exponent is the answer. So log base 4 of 1 is equal to 0. Let's continue on here. Log base 5 of 1/25. Sounds a little strange. Again, let me come off to the side. Base is 5. Power is what I'm looking for. The result is 1/25. Again, this must be some kind of strange exponent. How do you start with a 5 and end up with this tiny fraction here? Well, it's obviously not 0 as an exponent because 0 turns everything into 1. The only thing that leaves, the only other types of exponents we did were negatives and fractions. Here's what I notice about this one. I started with just a simple number like 5, and I ended up over here with 1 over something. In other words, it has the appearance of flipping, right? As if something got turned upside down. Well, there's only one kind of exponent that flips the base to the bottom, and that would be a negative exponent. So whatever's in this box, I'm pretty sure it's a negative. The other thing I have to think is, well, how do you go from a 5 to a 25? In other words, how many 5s does it take to make 25? And of course it takes 2. 5 times 5 is 25. If you put those two facts together, I think we've just figured it out. My exponent must be negative 2. Let's double check that. What would 5 to the negative 2 mean? Well, I don't like negative exponents, so I reciprocate the base, and that allows me to change the sign of the exponent. And then if I simplify that, of course I would get 1/25. So we've got it. The answer, remember all of this was scratch work, should be off to the side. The answer to the logarithm is negative 2. Negative 2 is the power you have to put on top of a 5 to get 1/25. If you see flipping, you should be thinking negative exponents. All right, moving on to the next one. Log base 16 of 4. Let's do our little help to the side here. So the base is 16. The power is what we're looking for. 4 is the result. Once again, 16 is my start. How do I go to a smaller number? Well, this is not going to be a regular exponent. It's certainly not going to be 0. I don't see any flipping. Nothing has turned into a fraction, so that means it's not negative. The only thing left to consider, it would be a fractional exponent. Fractional exponents, remember, had to do with roots, with rooting numbers. That's what you have to notice here. You have to go, oh, if I root 16, specifically if I square root 16, I get 4. Well, what fractional exponent was the same as square rooting? It was the 1/2 power. Remember the bottom, the denominator, told you what kind of root? So if I want a square root, the bottom needs to be a 2. 16 to the 1/2 power just means take the square root of 16, and of course the square root of 16 is 4. We got it. The answer here would be 1/2. You can see that this gets a little tricky. When you're doing the homework tonight, you should be practicing all of this by hand. That's the intention. We'll learn a little bit more about the calculator later, but this stuff is meant to be done by hand. Okay, final one. This is a strange one. It's got a bunch of letters in it. Log base b of the 5th root of b. So let's see. Let's write out the meaning. The base is b. The power is what we're looking for. And then on the other side here, I've got 5th root of b. So I have to come up with some kind of exponent that's going to turn a b into the 5th root of b. Well, hopefully that radical there immediately makes your mind go toward, once again, fractional exponents. It's got to be some kind of fraction. What fraction? Well, I don't see any kind of power. I only see a root. What kind of root? A 5th root. That means the denominator of my fraction must be 5. And since there's no power, the numerator must just be a 1. 1/5 power means 5th root. The fact that this was a letter, a B, instead of a number, it doesn't really matter. Doesn't really change anything. I can still tell that the power needed is a 1/5 power. Make sure you practice this stuff a lot until you really have it drilled in your head that a logarithm is a power.